One way to solve race conditions and achieve some kind of predictability in the way our code runs in a multi-threaded environment is by coordinating when a certain thread gets access to a certain variable. That's basically the problem here, right? You basically have two threads which grab something, makes a copy of it, works on the copy, and then puts it back. Well, it's hard for anybody to be able to grab it and do anything it wants and put it back at any time. What if you were to say, okay, a single thread picks up a value of I from the main memory. Now you say if another thread is trying to access that same value, say, hey, hold on, this particular code is still working on it. Wait for it to work on it and put it back to the main memory, and then you can pick this up, okay? So the solution is really to make sure only one thread can pick up a data element, right? And some thread is working on it, you kind of want other threads to wait, okay? So it's not as usually it's not as simple as just one element is being modified. Maybe a thread is working on 3 different variables at a time, and you want to make sure that only one thread is executing that piece of code which is accessing those 3 different elements, right? So it's not just one data element. It's basically ensuring that a certain thread is working on, let's say a piece of code is working on these data elements. Make sure that it's one thread at a time that can run that piece of code. So the way to do this is by using kind of like a lock and key model. We are familiar with the lock and key model, right? So if you take a hotel room, for example, right? You're running a hotel, and you have people renting hotel rooms, and multiple people rent the same room over different periods of time, right? You want to make sure that the previous renter checks out before the new renter comes in and checks in, because it'll be odd if the previous renter hasn't left the room yet and the new renter is entering the room, right? How do you prevent 2 people from accessing the same room? Well, you do that by providing a single room key, right? You don't give all your guests the room key to the same room, right? You have control over the number of keys. Assume you have a single room key. So the first guest has to surrender the key before the second guest can enter, all right? So the first guest surrenders the key, and that's what's essentially a check out. And then when the next guest comes in, they get the same key. So it is impossible for 2 guests to access the same hotel room at the same time, because it is controlled based on the key. So this is kind of how access is coordinated in Java as well. Let's say you have that piece of code which does value plus plus, and you want to make sure that only one thread can access value plus plus, can run value plus plus at the same time. Well, you have the ability to create a quote-unquote key, a virtual key that a thread needs to get before you access that statement and run that statement. And when it runs the statement, it's kind of like checking out. It's like, okay, saying I'm done, and it releases the key, and the next thread can access that key and execute that same line of code. Okay, so this prevents all these problems from happening. So this way of kind of synchronizing multiple threads from accessing data is what's referred to as synchronization. Okay, synchronization is to make sure that multiple threads, 2 threads, don't simultaneously access a critical data element. The key here is to remember that this is controlling data and not code. The way you control data is by making sure that a certain portion of code doesn't execute, but all you care about here is just the data, all right? Value plus plus shouldn't be interleaved among 2 threads. Whether that happens in code A or code B, it really doesn't matter, right? It's just the data that you're protecting. So this synchronization is thankfully provided for us as Java developers as a JVM feature. So there is a feature built into the JVM, there is syntax built into the JVM that we can implement to have this synchronization, to make sure that a certain piece of code is not executed by more than 1 thread at a time. So the way to implement this feature is by using a block construct. Okay, let's say you can actually, let's say this is the piece of code. You want to make sure only 1 thread executes at a time. You can kind of isolate it. Okay, you can say, hey, I want this particular thing to be isolated so that only 1 thread works on this thing at a time. Okay, this is fine. This is not the actual Java syntax, by the way, and I'll tell you why it's not actual Java syntax. Let's assume it was. Okay, let's assume we can say this particular line can be executed only by 1 thread at a time. Okay, is that fair? Well, it makes sense if it is just one object. Okay, let's say I have this is my counter class, and then I have an object of the counter class, and I'm incrementing a member variable of counter. Now it makes sense that only one thread is incrementing it at a time, because we've seen this particular step can span a longer duration. And now while you're running this increment, if some other thread calls this increment, well, you're in trouble, right? What's the counter value going to be? So you're basically saying, hey, this piece of code needs to be run by only one thread at a time. You can isolate this. But it doesn't make sense for you to block all other threads that are calling increment in that JVM. Why? Because there could be multiple instances, right? So let's say I have an object called counter A, which has, I'm calling the increment method to increment the counter variable of the counter A instance, and I'm calling another method of another object, counter B, and what is this going to increment? It's going to increment the counter variable of this instance. Now, if I were to ask you, thread A is running this thing, thread B is running this thing. Now, thread B wants to increment. Now, does it make sense for us to say, hey, thread B, hold on. Thread A is incrementing counter A, so you have to wait before incrementing counter B. No, it doesn't make sense. Thread B will go, hey, dude, I'm working on a completely different instance, so I don't have to wait. So it doesn't make sense to block all accesses to a certain method. Okay, so the analogy is like, if you have a hotel room and you say only one guest can use any hotel room at any time, well, that's wrong. What you want to do is have a way for, given a hotel room, only one guest can use that particular hotel room, right? That's the way you need to isolate it. So the way you write synchronization is based off of this model. It's based on a data-based locking. Okay, so here's how it works. First, you mark a data element as a lock. You can say, okay, this is my data element. This is what needs to be accessed one thread at a time, all right? And then what you do is you mark that piece of code which needs to be accessible by whoever holds the lock. It's almost like you're creating a key, and then you're saying this room can be opened by just this key. So any thread that wants to enter that room and execute that piece of code needs to first get that key, then run that piece of code, and then return the key. Okay, so this is how synchronization works. This is how synchronization is written in Java. So here's how it actually works. When the JVM runs, it creates this virtual lock from the data element. You say, I want the data element to be the counter instance, for example. You're going to say, okay, I'm going to create a lock for the counter instance A. So basically, any thread that needs to execute that piece of code needs to first get a lock that is represented by this counter instance A. Okay, so the JVM creates a virtual lock for the data element, which is the counter instance. And then any thread that needs to execute something which you have marked as isolated by that lock, well, the thread tries to acquire that lock. Okay, if it acquires it, then it can execute that synchronized code. And then when it's done executing that synchronized code, the thread finishes that executing block and it's done, then it just releases the lock. Okay. In the meantime, if there is some other thread that tries to execute that block, then it has to wait for this thread to release it. It's almost like you're saying, hey, someone else is working on this. Someone else has checked into this room. You better wait till they hand over the key. And then when they've returned the key, only then you thread can execute it. Okay, so the way this works is semi-declarative in Java, right? We're going to look at the syntax in the next video, but it's very declarative. You basically say, hey, this is the piece of code that I want synchronized. You don't do like, okay, fetch the lock. You don't release the lock. The acquire and release isn't imperative. You can if you want, but the way I'm going to show you in the next video is not imperative. You don't do all that stuff. You basically declare the area of code that you want to be accessed by one thread at a time. And you also declare what is the data element that it needs to be locked by. All right, let's take a look at the syntax in the next video.